Hello and welcome back. So far we have understood how decision tree classifier works. In another way, how it chooses the best features, and after choosing the best features it's going to split the data into multiple subparts and then builds the tree. So we are going to build a decision tree using decision tree classifier from scikit-learn. I have taken a simple dataset, iris dataset, where we have got data with sepal length, sepal width, petal length and petal width, and we have species. The target variable is species. When a new record comes in with these parameters, the model should be able to predict whether whether the species belongs to one of these three classes: Virginica, versicolor and setosa. Once after building our model, your the tree is going to look like this, and this is actually the picture taken from the ultimate tree built by the algorithm. So we are showing only depth 3 here, but the depth is going to be even more. We'll see that in a moment. In this, right, it is actually as first node or the condition, first condition it chose was petal length less than 2.5 and splitted the data into two parts. So it has got petal length less than 2.5. It has got all setosas came into one branch. In a single shot, all setosas came into one branch, and when it is greater than 2.5, right, again it need to do some more calculations and it need to split the data. So this is how the tree structure is. To measure the impurity of the columns and decide on which column to split first, it will use Gini index or information gain. We call that as criteria in scikit-learn. So let us try to build a model and see how it works. So I have taken decision tree from scikit-learn tree module, and decision tree I have taken depth 2. Intentionally I have taken depth. Even if you don't specify anything, there are default values and the model will work. And random state I have taken 42. Random state is just to define the state of the algorithm, or it is kind of seed in NumPy array, right? NumPy module. We passed the xtrain and ytrain. We built the model, and when you say tree classifier.classes underscore, you can see different classes in there, right? It is given the 0 index to setosa, 1 index to versicolor, and 2 index to virginica. If you do predict proba on the xtrain, you will see the numbers like this, right? When you see the numbers like this, this number belongs to setosa, this number belongs to versicolor, this number belongs to virginica. The order I know because the classes underscore is giving you the order, the same order in which the probabilities are going to be presented here. Whichever probability is high, the record belongs to that class. For first record, we have got 3 probabilities. Predict proba will give 3 probabilities. Even you can use the decision scores also. Right? Predict proba will give 3 scores. Whichever column has got the highest score, the record belongs to that particular class. So first record belongs to setosa. I have taken 5 records only. Second record also belongs to setosa. Third record belongs to versicolor. How do I know? Because of classes underscore I know. Okay. So the model is built and we can make predictions. When you use the model dot predict and pass xtrain, you will get predicted values. Here I wrote a small method to calculate confusion matrix, precision score, recall score and F1 score. I am passing xtrain and predicted value. I am getting 95% accuracy, 95%, around 94.9% F1 score. It looks like model is working a little underfitted. Okay, and test set we are getting around 97, but when 95 is not satisfied, the model is underfitted. So we can actually do fine tuning. How can we do fine tuning? Using gridset-cv. In gridset-cv we can pass param grid, and we can play with max leaf nodes and max depth. So if you see, there are other parameters also. Min sample leaves, min sample split, min weight fraction leaves, max leaf nodes, max features. These are all hyperparameters. In the cost complexity pruning, right, in the theory we understood before, I said that more number of leaf nodes will actually cause overfitting, or more depth will cause overfitting. But here the model is underfitting, so you can increase the depth here. See, the hyperparameter max depth I gave 2, and it is underfitting. That means the model is not complex enough. When model's depth is high, the model becomes overfitted, so we need to make the model a little complex. That way we can fix this underfitting problem. Or you can increase the number of leaf nodes, minimum sample leaves, right? You can increase that. So I am actually playing with the max leaf nodes and max depth. So maximum number of leaves, how many I can have. If I have more number of leaves, right, the model will be more complex. So I am actually using different parameters here. I have taken 1 2 3 4 5 6 7, and here 1 2 3 4 5 6 7. So I'm going to build 49 models, 7 into 7, 49 models, and I've taken cross validation 5, 49 into 5, that many models it's going to build, and it is going to find the best model. Gridset CV does that. Gridset CV gets the algorithm, this algorithm, and then gets the parameters from parameter grid combination. For 2 and 4 it will take, build a model, 2 and 5, 2 and 6, 2 and 7, like that, and 4 and 4, 4 and 5, 4 and 6, like that. It is going to build multiple models and find, it actually does cross validation internally and find the best model and gives us. So when I say best params, I've got max depth 6 and max leaf nodes as 8. So when I used the best params, I have got 99% accuracy on the train set and almost 100% on the train set. The data set is small, so it looks like it is not working well on the train set and working well on the test set. But when you have huge volume of data, right, you will get clear picture. This is how a decision tree model is built using scikit-learn's decision tree classifier. So we have seen how classifier works, decision tree classifier works so far, and in the coming session we will see how decision tree regressor works. Thank you.